Hi! So today we're going to do a video on the NAND gate and the inverting buffer stage. And what that is commonly called is a NAND gate or a not NAND gate. An inverter is just a not gate. So there you go. So let's analyze this circuit, and then I will go over to our little breadboard and you can see it working. Essentially, we have our 4 signals here, 1, 2, 3, and 4, and those signals come into these steering diodes over here that provide the logic forming array. You can have as many of these diodes as you want, provided we can get enough current into our transistor over here. So this is a good way to implement something like an 8-gate NAND gate or an AND gate, because remember, this is just this section right here is just the AND gate section of this. I'm sure if you look up any of those circuits out there that you'll come up with this AND gate portion here. This is standard AND logic that was implemented with just diodes back in the day. So we have our pull-up resistor here, and the way this works is if any of these inputs are low, current will flow through this junction here, and it will create a voltage drop across here, across this resistor, as a negative voltage starts here and moves over to this positive voltage here, and we'll get a drop that puts this at very near 0 volts in that manner. But if there are no negative voltages on the signal inputs, that means that the diode array here is never going to get pulled down, because remember, that's why we have these diodes here. And in this manner, we can know that if we have 1, 1, 1, 1 on this side, then we are going to get a positive voltage on this portion here. So it's an AND gate at that point, right? But we need to be a NAND gate, which is what this transistor here does. All this transistor does is invert whatever we have on the input on the output. That's it. If there was a way to implement this without needing a transistor, then you would see that a lot more. However, I don't know of one, and there's also the problems that you get when you're trying to cascade many different stages off of this, because the current handling capability, because of the voltage drops across these diodes, kind of reduces the maximum that you can work with here. Anyway, this is essentially how this works. We have all 1s over here, we get a 1 here, and that means we get a 0 here. That's it. It just pulls this turn on action, pulls ground down to the collector over here, and that's all. If we had any one of these or all of these be a 0 state, then we would get a 0 over here, and that would mean we get a 1 over here, like that. Let's take a look at what it looks like implemented. And let me just adjust this so it's in frame. And here it is. Right now we have these 4 diodes linked into this MC1404B, which is actually just a CD4040. It's just a Motorola part number. And we have my signal generator pumping in some frequency. Doesn't really matter. And we have our 4 diodes here, 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 and here. You can see they're all tied together in parallel on this end. And there's a diode for steering here. This is just so that we can use a negative resistance here and a positive resistance here on either side of the diode and get a sharper waveform. That's why it's called a steering diode, or why I'm calling it a steering diode here. And we have a 3904 transistor here with its emitter brought down to ground. Ignore the fact that this is the red wire. And its collector pulled up to 5 volts over here through this 10K resistor. as this section here detects that some of these segments are off and some of them are on, the NAND gate function brings out that 1 or 0 on this side is brought out over here to this point on the breadboard, and we have an LED flashing, which is just another branch of our collector here. And that's it. If you need like 16 inputs off of many parallel outputs, and there is almost no supply for the AND gates or the NAND gates that you're looking for, a massive diode array is probably going to be your friend. You could throw it through a hex inverter or hex buffer, and then you don't even need this transistor if you're using an inverter. A Schmidt hex inverter would be able to handle 6 of these different bridges with very good fan-out current capabilities. And that's about it. That's going to be the video this week. Not much, but there's been a lot going on. So that's it.